Back when I was droning on endlessly about, waxing poetic about dynamically learned MAC addresses, one question you might have had is, how long does addresses stay in the table? You might have thought, hey, Chris, those static entries might be a pain in the butt to keep up with, but they do stay in the table for an awfully long time. That is until you take them out. Well, the default aging time for a dynamically learned MAC address is 300 seconds. And that timer is reset anytime a frame comes in with that particular source MAC address. So as long as the switch hears from any host within a 5-minute period, that host MAC address will stay in the table. Now there is a way to change that value, and the command is MAC address table aging time, which you may have known, you may have seen in your NA studies. So if I came to you and said, hey, I really need you to change the MAC address aging time, the table's aging time to 10 minutes for dynamically learned addresses, you go, okay, no problem at all. And even if you knew or you were a little fuzzy, let's say, on, okay, I know it begins with MAC address table, but what is it after that? What do? You use iOS help. And you'd be amazed how many times you just can't quite come up with a command or the command syntax. You use help. It's like, hey, it's right there. Aging time. Set MAC address table entry maximum age. By golly, that's exactly what we want to do. So I will put aging time here and then 10 for 10 minutes. And you're done. You're wrong, but you're done. And those of you who got your CCNA with me, you're already saying, oh, here he goes. But this is so true, and it saves you so much time and so much unnecessary heartache, not to mention troubleshooting time. Anytime you have a Cisco iOS command with a numeric value in it, whether it's time-based or data-based, always use iOS help to see what unit they're using in the command. Because just time-based commands, for example, you'll have some that use seconds, you'll have some that use minutes, you'll have some that use seconds and minutes. I can think of one, exact timeout is like that. It's got a minutes and a seconds value. And some of them, especially when you're setting time, that kind of thing, it's, hours, minutes, days, year, that kind of thing. It only takes you a second to use iOS help. And I don't know why some people just have a mental block about it. It's like a sign of weakness or something. I'm pretty strong with this stuff. I use it all the time. I just use it to double check it. And what I did here, well, let's go ahead and repeat that command and just take the 10 out. And if I use iOS help there, not only do I see what the actual unit of time is, but I also learn something. Because the aging time in seconds, that means if I want it set to 10 minutes, I got to set it to 600 seconds. So the correct command here would be MAC address table aging time 600. But you also pick up an important bit of information there on the top line of iOS help readout with enter 0 to disable aging. So if you wanted to totally disable your MAC address, your dynamic MAC address entries, that is, their aging, you would just put a 0 there, MAC address table aging time 0. That would be it. They would never age out. You probably don't want that, but it could work for your particular situation. So that's another reason, for the MAC address table, again, always use iOS help to check out those numbers. Because like I said, in here with database commands, you got megabits, you got kilobits, you got gigabits. And when you start mixing those values up, you can end up in real trouble. So I shall now hop down from yield soapbox and we'll march forward. We're going to look at a walkthrough here, and then I'm going to set something up so we can look at it on live equipment as well. Because another factor in favor of these dynamically learned address table entries is the switch's ability to dynamically adapt to a change in the port. And to demo this, to begin with, I would need to know the port router 3 is connected to. What is that command that gives us information about directly connected Cisco devices? Hintity hint hint, directly connected Cisco devices. I'm sure you remember it. And I'm going to run it here, and we'll look at it on the board too. But it shows CDP neighbor. And I believe there's an S on the end. Yeah, technically there's an S on the end. Shows CDP neighbors. Tons of information. And CDP is so important that we actually have a full section on it later in the course. So we're going to come back to this command. But it's a great command to see basic information about your directly connected Cisco neighbors. Remember, it only works for directly connected devices, and those directly connected devices have to be Cisco devices. So I ran that here on the board, and you could see, here's the CDP neighbor table. and we're looking for the port that router 3 was connected to, and there's that information right there. No need to walk down to the server room, fight with those cables, just run show CDP neighbor and you're good. Now, what I did then is use the show MAC address show MAC address table interface command to get information only about that particular port. Now, I could have run show MAC address table dynamic to get a list of all dynamic entries, but when we have, 48 or more, dynamically learned addresses, this interface filter is one that I think you'll want to use. But then what happens? Port goes bad. I don't know what happened to it. It was a good young port, but when it grew up, it just went bad. Well, with dynamically learned addresses, all we need to do is move that cable to a port that's working. And in this example, I moved it to 0/11, and then I went to check the full dynamically learned address table, show MAC address table dynamic. And you can see the entry for that MAC address has been moved to 0/13. It's just that fast. No aging was necessary, because as soon as the switch sees frames coming in from router 3 from that MAC address, but on a different port, says, okay, wait a minute, this one has obviously been moved, and I will now recognize fast 0/13 as the correct port for this particular MAC address. Nothing to it. Now, there is one thing you have to do manually in that situation, and that is changing the VLAN membership of the port. Now, an earlier show command, we saw over here under VLAN that particular port was in VLAN 13, but our Cisco switch ports belong to VLAN 1 by default. Now, you likely remember how to change a port's VLAN membership, and if not, here's a reminder. It's the switch port access VLAN command followed by the number of the VLAN. And if you're a little fuzzy on VLANs, we're going to take care of that in the next section, believe me. But I just wanted to show you this command. You would verify it with show VLAN brief. This is very abbreviated output. You'll see the full output in the next section. And really, that's all there is to it. Just a couple of different names here I want to hit you with, because I often joke, and it's not really joking, it's more like ribbon on the square, that we have to have more than one name for important things in networking. And the MAC address table has several different names. We call it the bridging table, even though we really don't use bridges often anymore. We call it the switching table. We call it the MAC address table. Some people call it the physical address table. I'm not much on that one myself. But one important name for it is the CAM table, the Content Addressable Memory table. And for layer 2 switching, having just the CAM table is enough to get the job done, because we're switching. That's it. That's all a layer 2 switch is going to do. But multi-layer switches, which we're going to see in action throughout the course, not yet, but throughout other parts of the course, they have other challenges because they can do things at layer 3 as well. So besides switching, they can perform routing, they can perform advanced security features, and quality of service, just to name a few. Now, for those tasks, we need the help of another table. The CAM table is not enough to get all that done. We have the ternary, pick your pronunciation, Content Addressable Memory table. Now, while the CAM table lookups use 2 values, no surprise, 0 and 1, TCAM tables have 3 values, 0, 1, and X for don't care. And it's very common for multi-layer switches to have multiple TCAM tables to go along with the multiple functions that a multi-layer switch has to be ready to handle. There will be more information on the TCAM and the multi-layer switching table. I don't think you'll be working with the table itself a great deal on your exam, but we have to know a lot of multi-layer switching techniques that use the TCAM table, and that's definitely coming up in our multi-layer switching section. Now, coming up next, something brand new. It was not in your CCNA studies, but it's a fundamental part of switching right now. It's something called the SDM. And I just want to give you this note now, and I'll give it to you at the beginning of the next video just as a quick reminder. This is not Security Device Manager. That is a product that was used in your CCNA security studies. It's actually now gone. Cisco doesn't support it, but oddly enough, it's still in the current CCNA security exam as I create this video. I just want to draw a line for you very clearly. So if you have your CCNA security certification, CSDM, you can't think about Security Device Manager. This SDM is the Switching Database Manager, and we will start working with SDM and some templates in the very next video.